What a time to be alive in the open source AI world. Just as we are all catching our breath from the massive Ideogram 4 release this June 2026, another blockbuster open source model has just dropped and everyone is talking about it. Craya 2. It's fast, it's lightweight, and the image quality is outstanding. Today, I'm giving you the complete guide to mastering this highly flexible, fast-generating model inside ComfyUI. I'll teach you how to set up an advanced, local, uncensored LLM prompting system for Krea 2. I'll also show you step-by-step how to train your very own consistent character, Laura, using AI Toolkit so you can put yourself or any character directly into the scene. If you're excited to start, go ahead and drop a like on this video, subscribe for more advanced ComfyUI guides, and ring that bell to get notified the second my next tutorial drops. We'll start with a completely blank canvas. To make things easy, I'm first adding a simple note node here. This note contains the direct links to download every single Krea 2 model you need. Just right-click, save each model into its correct folder within your main ComfyUI directory, and you're good to go. Now, let's build the foundation. We need 3 basic loader nodes. First, a load diffusion model node, then a load clip node, and finally, a VAE loader node. If you've just downloaded the models and they aren't showing up in the drop-down menus, don't worry. Just tap the R key on your keyboard to refresh ComfyUI and it will instantly detect the new files. For our diffusion model, we are choosing the Krea 2 FP8 Turbo version, not the raw one. In our clip loader, we'll load the Qwen 3 VL 4 billion FP8 scaled version. And for the VAE loader, we're starting with the Qwen image VAE. Though keep in mind, we're going to swap this out later for an alternative VAE that I found works much better for this specific model. Next, we need to set up our prompts. Let's load 2 clip text encoder nodes, one for our positive prompt and one for our negative prompt. Connect both of these to our clip model. In the negative prompt, I'll add a simple term like watermark to keep our outputs clean. With our models and text encoders ready, we need a K-sampler to process all this data. Connect the model input, the positive conditioning, and the negative conditioning to the sampler. We also need to define our canvas size, so let's load an empty latent image node and connect it to the latent input of the K-sampler. This lets us specify the exact width and height of our generation. Inside the K-sampler, let's set the seed to fixed. This gives us much better control. If we want to tweak the prompt slightly, but keep the same composition, we can do that easily. Because this is a turbo model, we only need 8 steps to get a highly detailed image. We'll set the CFG scale to 1. This model pairs incredibly well with the Euler Simple sampler, though you can definitely experiment with other samplers like Euler SDE later on. To turn that raw latent data into a viewable image, we'll add a VAE decode node and connect it to our VAE loader. Finally, let's attach an image preview node so we can see what we generate. That is the entire basic pipeline for Krea 2 Turbo. Now, we just need a positive prompt. I've prepared a detailed one beforehand. Krea 2 is very flexible and works with short, medium, or long prompts. Later in the video, I'll show you how to automate this prompting process using a local, uncensored LLM. Let's set our resolution to the standard 1024 by 1024 and hit Q prompt. Look at that, we ran into an error. This is a common issue related to the conditioning and the Qwen 3 VL model. To fix it, we need to set the correct type on our clip loader. Change the type drop-down to Krea 2. If you don't see that option or you still get an error, it simply means your ComfyUI setup is a bit outdated. You can easily fix this by updating via the ComfyUI manager or running a git pull in your terminal. Let's run it again. There we go, it's generating. The turbo model is incredibly fast. In terms of speed and VRAM usage, it feels very similar to Z Image Turbo or similar fast models. And here is our first generated image. For a first try, Krea 2 handled this prompt beautifully. The composition is spot on, an eye-level medium shot of a redhead woman sitting on rough concrete stairs, with a concrete wall on the right and some greenery in the upper left. It has a great, relaxed, lifestyle photo vibe. Fortunately, our model handled the lighting beautifully. It's soft daylight coming from the front and upper left, casting very gentle shadows. The face looks natural without that artificial plastic sheen. The smile is genuinely believable, and the hair has realistic variation. The outfit also matches our description: a white cropped tank top, black wide-leg trousers, and tan strapped sandals, all with natural-looking fabric folds. What really impressed me is how well it handled the hands and feet. Anatomy is usually a weak spot for these models, but her hand resting on her cheek looks natural. The toes and sandals are clean, and her body feels realistically weighted on the stairs rather than looking like she's floating. Here is my first big tip for working with Krea 2. Change the VAE from the Quen image to the one 2.1. It is fully supported and does a much cleaner job with overall image coherence. You might not notice a massive shift immediately, but over multiple generations, the difference becomes very clear. Now, let's push the resolution. This model is capable of generating high-resolution images directly without needing external upscaling workflows. Let's set it to 2048 by 2048 and run it again. What stands out here is how well the composition holds together at higher resolutions. Many models start breaking down when pushed this far, introducing waxy skin, distorted hands, or double heads. Here, the image actually becomes cleaner and more defined. The face is sharper, the individual strands of hair are clearer, and the skin texture looks incredibly natural. You can also see a massive improvement in the textures of the environment. The concrete stairs and wall have much richer detail, the folds in the dark trousers are more defined, and the hands and feet still look structurally sound. The model uses those extra pixels to add real depth, clarity, and realism without making it look over-processed. You can easily switch this to a vertical aspect ratio for mobile-friendly shots, or use a wide landscape ratio. The model is highly flexible with its dimensions. Now let's take things a step further and add a custom LoRa trained on my own photos to generate consistent images of myself. I'll add a load LoRa node and select my custom character LoRa file. Don't worry, I am going to show you exactly how to train your own high-quality Krea 2 character LoRa in just a moment, so keep watching. We'll connect the model output from our LoRa node to the K sampler and pass the clip output through to our clip text encoders. Let's run the exact same prompt and see how it looks. The LoRa did a fantastic job of capturing my likeness. The facial structure, skin tone, and overall appearance feel distinct and recognizable rather than a generic AI face. Even better, it doesn't overpower the rest of the prompt. We still have the exact same pose: the concrete stairs, the white top, the black trousers, and the soft lighting. A good character LoRa should inject identity without ruining the scene layout, and that's exactly what's happening here. Now for the advanced setup, I'm going to show you how to connect an Llama node to load a local Gemma 4 LLM. This will process a reference image using a custom system prompt I created, automatically generating a highly detailed text prompt tailored specifically for Krea 2 Turbo. I won't go into detail on how to install Llama or Gemma 4 in ComfyUI today, but you can check out my dedicated video on that right after this one. To set this up, let's load a load image node to bring in a reference photo. This won't copy the image exactly like a control net would, but it will analyze the composition and style to give us a highly similar result. Next, we'll load an Llama chat node and an Llama connectivity node. I'll paste my custom system prompt into the top text box, and we'll leave the lower user prompt box empty for a moment. I'll explain how we can use that in a bit. By the way, if you want to skip the manual setup, you can download this entire workflow from my Ko-fi page for free, or you can choose to support the channel there. The link is right down in the description. Let's connect our reference image to the Llama chat node, and then route the output text directly into our positive clip text encoder. This means the prompt generated by Gemma 4 will feed directly into our K sampler automatically. Make sure you have Ollama running in the background of your machine so it can load the Gemma 4 model. Let's run the workflow. This will take just a moment longer since the LLM has to analyze the image and write the prompt first. If you don't want to run a local LLM, you can copy my system prompt and paste it into Grok, then copy the resulting text back into your positive prompt box manually. Looking at this test, the workflow did an incredible job preserving the character identity, the outfit style, the pose, the chair, and the overall composition. The only tiny detail it missed was the exact hair color, but that is very easy to resolve. We can use the lower user prompt box in our Ollama node to override any details analyzed by the vision model. For example, if I write, "Make the woman with fiery red shoulder-length hair and green eyes," the LLM will prioritize those specific details in the final output, regardless of what's in the reference image. Here is a quick tip. This model does have some built-in safety filters that might block certain prompts. You can easily bypass this by using a custom LoRa called Conditioning Krea 2 Rebalance. You can grab that from GitHub, and I've also linked it on my Ko-fi page. Just connect it directly between your clip text encoder and the K-sampler. I won't be running it here for obvious reasons, but if you generate that style of content, this is the exact tool you need. Let's look at another example. The reference image here was originally generated using Ideogram 4. Even though that reference image features a dark-haired woman, our workflow successfully used our user prompt to override those traits and replace her with our redhead character. The reference image guided the pose and framing, while our prompt maintained the character identity. The realism here is fantastic: the skin texture, the lighting, and even the text rendering on the shirt. Crea 2 is surprisingly good at rendering clear, legible text. To make things easier for you, I've also put together a list of fully supported aspect ratios that you can quickly reference and use in your own projects. After testing Crea 2 with reference images, custom LoRa's, and LLM-assisted prompts, my impressions are highly positive. Its absolute biggest strength is sheer speed. It generates images almost instantly, and in many of my realistic portrait tests, it actually delivers better quality and texture than other turbo models like Z-Image Turbo. Now, it might not fully match Ideogram 4 when it comes to raw prompt adherence or highly complex scenes, but Ideogram is significantly slower and requires a lot more VRAM. Crea 2 is light, fast, and highly responsive. Plus, the fact that it supports custom LoRa so well makes it incredibly powerful. Once the community starts training and sharing more specialized LoRa's, we are going to see some truly spectacular results. Now, let's walk through how to train your own consistent character LoRa for Crea 2 Turbo. If you haven't watched my previous video on training LoRa's with Ideogram, I highly recommend checking that out first, as it shows you exactly how to install AI Toolkit, the tool we'll be using to train our LoRa's locally or in the cloud. Inside the AI Toolkit user interface, we'll start by loading our dataset. I'm using the exact same set of images and text captions that I used in my previous tutorial. Under New Job, let's configure our settings for the best possible results. First, give your LoRa a name and set a unique trigger word. Next, select the Crea 2 Turbo model from the dropdown. If you don't see it listed, simply run the update batch file in your AI Toolkit folder and restart the app. We'll enable the low VRAM option to keep things efficient. This time, instead of a standard LoRa, we are going to train a low KR with a rank of 4. We want to save our progress every 100 steps, up to a maximum of 5 save checkpoints. We only need 500 total steps for this training, meaning it's going to be incredibly fast. You'll actually start seeing great results around step 200. Let's change our optimizer to Automagic and set the time step type to sigmoid. Keep the rest of the training parameters at their default values. Under the Dataset tab, load your target dataset folder. If you are running on lower VRAM, set your training resolution to 512 or 768. If you have 24 gigabytes of VRAM or more, you can go all the way up to 1024. For our sampling settings, let's disable walkseed and set it to generate a sample every 100 steps. I'll clear out most of the default sample prompts here and just keep 2, making sure to update them to describe my target character and include my custom trigger words. That's all there is to it. I've made this exact configuration file available for free on my Ko-fi page, so you can easily download it and load it right up. With everything configured, let's start the training process. The very first time you run this, AI Toolkit will need to download the base Krea 2 models, which might take a few minutes depending on your internet connection. Once that's done, the training will begin. Depending on your GPU speed and available VRAM, completing all 500 steps should take around 1 to 2 hours. If you're using a cloud service like RunPod, I highly recommend choosing an RTX 5090 or an L40S graphics card for the absolute fastest performance. You can monitor your generated samples as the training progresses to decide exactly when to stop and export your model. As you can see here, by step 200, the sample images already look remarkably consistent and accurate. From there, you can download your best checkpoint and start generating. If you find this workflow helpful and want to see more content like this, please take a quick second to leave a like, subscribe to the channel, and turn on notifications so you never miss a tutorial.